Alright, so we have this function here, and we want to take the second derivative of it in order to figure out the intervals of x in which the function will be concave up and concave down. So first things first, let's just determine the first derivative. So just a simple polynomial, so bring down the 3, multiply by the 4, get negative 12x squared. Subtracted 1 from the 3. Over here I have negative 6x squared, so I can bring down the 2, multiply by the 6, I get negative 12x. And then over here, negative 72x. That's just negative 72, right? Because there's just one x over here. And the derivative of 31 is just 0 because that's a constant. Great. And now I will take the second derivative, because we're concerned with concavity today. So bring down the half. So I get negative 24x. And over here, I just obtain negative 12. And the derivative of negative 72 is just 0, because that's a constant. And now that we have the second derivative, I'll make it equal to 0, so that we can find the values of x in which we can find the points of inflection. In this case, we're only going to see one point of inflection. So add 12 to both sides. We get negative 24x equals 12. Then I can divide both sides by negative 24. They cancel out, so I get x equals 12 over negative 24, negative half. Great. Now, what do we do? I will throw in the negative half over here into this little number line. And I'll label this f double prime of x. Now what I want to do, so we know that there's a point of inflection, essentially, when x is negative half. What does that mean? That concavity changes at negative half. So what do we do now? Well, I'm going to plug in a value of x into f double prime of x. That is smaller than negative half here, so I'll pick a negative 1 perhaps. So I can figure out whether the graph of the function is concave up or concave down at this point. So plug in negative 1 here into the second derivative, minus 12, so I get 24 minus 12, it's positive 12, so it's positive over here. What does that mean? What does that mean? Well, that will mean that the graph of the function to the left of negative half is concave up. So this is concave up until half. At half, it's going to change concavity, and it's nice to test it anyways. I'm going to plug in. We can't, well, in this case, I guess we could assume that it's going to be concave down, but I wanna prove that by plugging in a value that is greater than negative half for x. So plug in 0. So that'll be negative 24 times 0 minus 12. So I get negative 12. It's a negative value, so therefore the function's concave down. The graph of the function's concave down to the right of negative half. So that's it. Concave up when x is smaller than negative half, and when x is greater than negative half, the graph is concave down. And that's it.